Bismillahirrahmanirrahim. All right, so we have worked with the physical layer and the Ethernet layer, and now we are going to move on to the next layer, which, if you remember, I told you that we have two very important layers in this course. Ethernet layer is important because it gets you a good understanding of what a network is, what a protocol is, how things communicate with each other, basic things which help you understand larger concepts. But for us, especially in computer science, software engineering, high level developers, we are not really concerned with the Ethernet layer. So we don't usually concern ourselves with that. Our concern is primarily with this layer, which is the internet layer in TCP/IP model, or the same thing is called the network layer in the OSI model. Okay, so it's the same thing, exactly the same thing. They call it the network layer and they call it the internet layer. Okay, so the word network is very generic. I mean, it's very general. Network, everything is a network, right? So they call it a network in the sense that it's going to allow you to communicate from one network to another network. That's why it's called a network layer. And it's also called the internet layer in the TCP/IP model because this is the layer which allows you to communicate with any device over the internet, right? So now we are moving from the local area network over to wide area networks, which essentially means we are now going to be able to communicate with the whole world. Okay, so essentially that's the material we're covering in this lecture and probably in one or two more lectures as well. So this layer is in itself quite simple. It's very important, but it's quite simple. In fact, we have already taken a look at most of the concepts which are in this layer. We've already taken a look at them. I've been introducing them slowly so that when you actually get to the layer, you would be able to understand it well. Okay, it's simple, but it's very important that you understand it well. Okay, so what's the idea? The idea is that we saw this case study earlier on in which there was one LAN which was 192.168.1.110, and this wanted to communicate with another LAN which was 172.16.1.99. Okay, so you had these two LANs, and in the middle we had the router, and the router was able to do the communication. Okay, so in this layer we are going to discuss the semantics and the protocols involved in deciding what these numbers are, right? So the IP address that we've already seen before, now we are going to define the rules for IP address, and we are going to see what implications it has. And this is the only thing that you need. These aren't many slides either. It's not that long of a lecture. So I'm going to try to keep this brief, but the concepts that we do study are very important. Okay, so let's start off with the idea that you have already seen quite a few times. The idea is that in an IP address, which is a 32-bit address, okay, you'll see what hierarchical means in just a minute. It's a 32-bit address. It has a network portion and a host portion. Again, you've seen this before. Okay, when determining the network portion versus the host portion, you must look at the 32-bit stream. So you have to look at all of them, and a subnet mask is used to determine the network and host portions. So you have seen this before. You may not remember this, but I'll tell you, when we configured the IP address using DHCP, or even when we did the static IP configuration, we had something when we entered 192.168.0.1, for example, for the web server or for the DNS server or DHCP server. When we entered this, we had a box below it. So this was the IP address box. And I told you to click on the box below it, and that automatically populated it with some numbers. I'll tell you what those numbers are. So they were 255.255.255.0. Okay, this thing is the subnet mask. And essentially this lecture is all about what a subnet mask is. Okay, so in order to decide in a given IP address what the network portion is and what the host portion is, you look at the subnet mask. If you remember, we had this in the quiz and in the midterm as well, that there are a certain number of bits which are given or dedicated to the network portion, and the rest of the bits in the 32 are dedicated for the host portion. Okay, but how do you define those, right? In the exam and in our general discussion, we say 16 bits are for the network or 24 bits are for the network. But how do you tell it to the computer? You tell it to the computer by using the subnet mask. Okay, so that's all a subnet mask is. A subnet mask essentially is going to be a sequence of numbers, zeros and ones. Anything which is a 1 is going to belong to network. Anything which is a 0 is going to belong to the host. Okay, we have examples of this. Okay, So subnet mask is what exactly. So 255, we'll convert it to binary and then it's going to make sense. It's in binary, there is only 1 and 0 obviously. So it's either 1 or 0. So if it's a 1, it's a network portion. If it's a 0, it's a host portion. Okay, we have examples. I understand it. It doesn't make sense right now. Right? All right. So these are some examples over here. So you can use the subnet mask. For example, you have the example of 255.0.0.0. If you write it in binary, it's going to be 1111111. So this 8 bits, all ones, comes to 255. Okay. So if you don't believe me, you can go do the conversion. But 8 bits, so 8 bits, 8 bits, 8 bits, 8 bits, right? 8 fours are 32. You've done this calculation before. So if you have 8 bits, all ones, it in decimal is 255. Okay? In decimal, it's 255. If you want to convert it, you can, but I encourage you to do it at least once. Like convert 255 into binary or convert this 7 ones to decimal so that you actually believe that this is 255, but it is 255, okay? So 255.0.0.0, so it's the same thing, okay? So 8 bits actually, not 7 bits. I think I said 7, 8 bits, right? So because it's 8 for the 32, okay? So you can also represent this whole big thing using a much smaller number, which is /8, okay? So /8 in networks, whenever you see anywhere in computer networks, whenever you see /8, it means it's the subnet mask. And what is the 8? The first 8 bits are ones, everything else is a 0. Okay?
Means
so
the first 8 for the network?
First 8 for the network, exactly. The rest is the host, exactly. Okay? So you have 3 ways of writing the same thing. They're all the subnet masks. In certain cases, that makes sense. The middle one never makes sense because you don't do this. You get in the habit of using that and this. Okay, so the first column and the third column, they are used very commonly, but this one is used for the calculation, which after a little bit of time, you don't need to do by hand. You just kind of remember it. Okay, but initially when you're trying to get used to it, you have to look at this binary because the actual calculation is in binary. Okay, so you can also have 255.255.0.0, which is /16. Okay. 255.255.255.0, which is /24. So first 24 bits are ones, the others are 0. 1 means network, 0 means host. Okay. You can also have things which are not on the boundary of the dot. Right. So the first 3, you can see that first 8, first 16, first 24. So it's on the boundary of the dots. Okay. But you can also have things which are not on the boundary. So you can have /25 as well. Okay. What does that mean? It means you have to now convert this is 255.255.255. This thing over here, which is 128. Okay, so 100000000 is 128. You just convert it. So now the subnet mask in this /25 is 255.255.255.128. It has its own special purpose. We'll get to it by the end of this lecture. But for now, if you understand these 3, it's fine. Okay, makes sense? It's the same concept. How many ones? Initially. The ones in subnet mask are never going to appear after a 0. They're all going to be to the left. Okay. So if you say /26, it means first 26 out of 32 bits are ones and the others are zeros. So it's not complicated. Why you do it is important. So this thing is called a prefix. Okay. So a prefix length. So prefix means things which come before others. So ones come before zeros. So that's why we call it a prefix length. How many ones come before the zeros? So that is this thing over here, prefix length. Okay, it is what is called a slash notation. Okay, so slash notation essentially means you write an IP address 192.168.0.1 and you can, so let's make this 9, and you can say /24. It means it's using the subnet 255.255.255.0. Make sense? /24 means this IP address has the subnet 255.255.255.0. Make sense? Okay. So sometimes you want to write the whole subnet mask. Sometimes you can just write slash notation. Okay. Depends on what you're trying to achieve. We don't actually use the binary one in practice. We use it just for the calculations. Okay. So let's see what the calculations look like. So if you have an IP version 4 host address, so we're going to do IP version 6 inshallah next lecture. probably. But if you have an IP version 4 host address, which is 192.168.10.10, and you are given a subnet mask, which is 255.255.255.0, which is 1111111, 1111111, 11111, and 0000000. Okay. So if you have this, in order to calculate the network portion, this is important. In order to calculate the network portion, you basically do a bitwise AND. Okay, this operation is called ANDing. So you're doing the AND, so ANDing. It's not English, proper English, but this is what the operation is called. Okay, so how do you calculate which portion is the network? Now, for a computer, we can say, just take this, this is the network. How does the computer do it? Takes the subnet mask, do a bitwise AND. A bitwise AND is 1 and 1 is 1, everything else is 0. Okay, so 1, 1, 1, 1, 1, 1, 0, 0 and 1 is 0, and so on. You come all the way up till over here. So what this is going to do is, it's going to take this and basically copy this over here. Okay, why? Because if initially it was a 1, it will AND with a 1 to give a 1. If it was initially a 0, it will AND with a 1 to get a 0. So it's essentially being copied down. Okay, so binary arithmetic really works out, or binary operations are very clean because of these properties. If you AND anything with 1, you get the same thing back. Okay, so if you AND the original IP address with the subnet mask, the network portion is going to come down as it is, and the host portion is basically going to turn into 0, because it doesn't matter whatever was at the top. If you AND it with a 0, it's going to turn into a 0. Okay, make sense? So essentially 192.168.10.10, which is this IP address over here. If this is /24, which is this subnet over here, if you want to calculate the network portion, you convert this /24 to subnet mask 255.255.255.0. You convert it into binary and then you AND it. But the end result is essentially that the first 3 portions are going to be copied as it is. So 192.168.10, and the final thing, which is the host portion, is going to turn into a 0. Make sense? So the first portions, because they are being ANDed with a 1, copied as it is, and the final thing turns into a 0. For us, it's much easier to just do this. So in practice, we just do this. But a computer cannot look at things. So how does the computer actually do it? Using the subnet mask.
And of course, and final, we will use which.
Either way. I mean, both are fine. I mean, it depends on what is given to you. If, for example, in an exam of any sort, if you are given 255.255.255.0 and the IP address, then it's much easier to just look at it and do it. If it's /24, then you have to be careful. What if it was /25? Then like you have to do binary. Make sense? If it's /25, then you cannot do it directly. You have to do a little bit of binary conversion, and then it's going to make sense. Okay? But you understand the concept, right? It's simply ANDing. Sometimes us humans can do the AND like that. Sometimes we have to think about it. Okay? But the operation, even if you have to think about it, the operation itself is fairly straightforward. Make sense? Okay? I'm going slow so that you actually absorb this, because this is probably the only time you're going to do it by hand. Afterwards, when you get into practice and you're doing computer science, proper computer science, it should come to you naturally. You don't actually like do the calculations. It comes naturally. Okay? All right. So this is clear? Now this is essentially all we're doing today. So if this is clear, then it's fine. The only question that remains is, what is this thing over here that we got? Okay? This thing is the network address. Remember, we have a network of PCs. Each PC has its own IP address, which is unique, right? IP address has to be unique. Each PC has a unique IP address. But how do you identify this whole network? Okay. For example, this thing has many PCs, but this combined is a lab, COAE 232. Okay. COAE 232 is not this PC, not this PC, not this PC, but the whole thing, the whole collection. Okay. So the whole network has an address, and there is a purpose to that. We'll get to that later on. But a whole network address is retrieved by ANDing the IP address, any IP address in the network, with the subnet mask. Make sense? Okay, so if I give you two IP addresses, you've done this before, but if I give you two IP addresses and the subnet mask and ask you if they are on the same network, can you do this? You AND the subnet mask with this, you AND the subnet mask with this, and if the network address that you get out of it, if they're the same, they're on the same network. Sense? I'll say this again.
Means we remove the host portion.
Essentially, yes. You zero out the host portion. So the host portion is zeros out. You don't remove it. So the network address is not 192.168.10. No. Network address is 192.168.10.0. So the word remove is kind of wrong. So you zero it out. But I understand what you're saying. So yes, exactly. Right? So the concept is simple. Agreed? Everybody agree? The concept is simple. It's not complicated. It's when you have too many numbers coming at you together, then you get confused. But just look at one IP address and one subnet mask at a time and you will be fine. Okay? All right. So for example, if you see something like this, it's like, what is going on? So just try to do one at a time. So here's the things that we're doing. We are looking at the network address, the host address, and the broadcast address. So there are three types of addresses which are important in a network. Okay? So one is the host address, which is, IP address. The whole IP address is the host address. Okay? You have already seen how to calculate the network address. Take the subnet mask, zero out the host portion, and you get the network address. If you turn the host portion all to zeros, you get the network address. If you convert host bits all to ones, you get what is called the broadcast address. Say this again. You have an IP address 192.168.10.10. It's the host IP address. Okay, so that's the address of host. Make sense? You've used this many times up until now. If you take the host portion and convert it into zero, that's the network address. All zeros in the host portion. That is the network address. If you take the host portion and convert those bits, just the host bits, all to ones, you get the broadcast address. Okay? Zeros gives you the network address, ones gives you the broadcast address. Okay? We'll see what they do later on, but for now, this is what we have. So for example, you have any IP address. So let's say 192.168.10, okay? 192.168.10.10, and you have the subnet mask, which is 255.255.255.0 or /24. Okay? Make sense? So this is the information that I've given you. There is an IP address 192.168.10.10, and the subnet mask is /24, which is equal to 255.255.255.0. Okay? Make sense? This is the information that I've given you. Now I'll ask the question. What is the IP address in this whole thing? You don't have to do anything. It's given to you 192.168.10.10. So 192.168.10.10. So let's write that over here. 192.168.10.10. So this is your IP address. How do you convert this into the network address, or let's say how do you find the network address using this and the subnet mask? You AND them together, okay, which essentially turns the host portion to 0. So 192.168.10.0. That's your network address. Okay. If you take all of them and convert them to ones, the host portions, if you convert all of them to ones, it's going to turn into 255. Right? All ones, 8 bits is 255. Okay. So if you do this, this is going to be 192.168.10.255. This is your broadcast address. Okay. You know what a broadcast is used for, right? So a broadcast is if you want to send a packet to everybody on the network, you use the broadcast. Okay. So on the Ethernet, you've seen what a broadcast address looks like. It's FFFFFFFF, all Fs. In IP, it's slightly different. It depends on your network address. So take the network portion and convert all the host bits to ones. So this is 11111. This turns into 192.168.10.255. This is your broadcast address. Okay. The steps are easy, but you have to do it once. Okay. Make sense? So what's remaining? What's remaining is everything in the middle, any other combination over here. Okay. So all zeros is a network, all ones is a broadcast. So everything in the middle, 0000001, 0000010, 0000011, and so on. All of the other things, 1001010, everything. All of these are called host addresses. So the first address that you can have, let's get rid of this. The first address that you can give to a host is this thing over here. 192.168.10.000000001. This is the first address that you can give to a host. It's a valid host address. 192.168.0.0 cannot be a host address. Why? Because it's dedicated for the whole network. Okay? You cannot call this PC COE232 because then people are going to be confused. Are you talking about the whole lab or are you talking about this PC? If you say COE232 is not working, what does that mean? The whole lab is not working or this PC is not working. So you cannot give the network address to a particular host. It's invalid. It's an error. Okay? You can also not give the broadcast address. Okay? So you cannot give the broadcast address to a particular host. Why? Because other people, when they want to do the broadcast, they're going to be using this address. And if you use it for a particular PC, then how do you send information to this PC? Okay? Make sense? So these two are not valid host address. Anything in the middle, starting from 0000001 to 1111110. This very final one, this final thing has to be a 0 because if you convert this to a 1 as well, then it's going to turn into a broadcast address. So you cannot do that. Okay. So the valid addresses that you have is 192.168.10.1 all the way up to 192.168.10.254. Okay. Over here, 192.168.10.0 is the network address and 192.168.10.255 is the broadcast address. Make sense? Okay. You have a choice to use all of these for your hosts within this network. Make sense? Okay. All right. So typically, this 192.168.0.1 is typically given to the gateway. You don't have to, but generally it's given to the gateway, right? Because by convention, everybody knows that if I'm going to communicate with the gateway, what's the IP address? You don't have to think about it. It's always your network portion .1. Okay? Make sense? All right. Sometimes it's 192.168.10.1. Sometimes it's the last address. But in practice, so in all the slides and in all the books that you read, everybody is going to say by convention, you either use the first address or the last address for the gateway. But in practice, it's almost always the first address. Okay, nobody uses 254. You have to type it, and computer scientists are lazy, right? So it's easy to type 1 than 254. So, okay, so generally in practice, the first address is given to the gateway. Make sense? Any questions about this? Okay, so now we have to explain this in further detail. If you understand this, this is all we're doing. So as it defined in the RFC 1918. So I have to explain this RFC very briefly. It's okay if you don't understand it. It's not that important, but this word comes up again and again in networks, so you have to understand it. The way the standardization of the internet works is, because we say whenever we come up with a protocol, everybody in the world has to agree to it. Right? That's what we said in the beginning. That's what networks is. Everybody has to agree to it. So how do you do this? You cannot sit down and decide on something and then say, this is what everybody should be doing. People are going to fight you. They're going to say, no, we don't want to do this. Okay, so the way you do this is, you come up with a solution, right? If you are a standardization body, an organization which is supposed to do the standardization, you come up with a problem, you come up with a solution, you write the whole thing. This is what we are intending to do. This is the proposal. This is what we are doing. Please look at this, and before we implement it or we say to people to accept it, take this and give us your comments. What should we change? What problem can you find in this? Okay, so it's a request for comments. In short, it's RFC. Okay, so whenever a new standard has to be developed, the standardization body comes up with an RFC, gives it a unique number. So this particular thing was RFC 1918. You don't have to remember the number. It's okay. It was just some request for comment. You have to understand what a request for comments is. It's just the standardization body asking the whole world. It's public information. It's anybody can contribute. Anybody can comment on this. Okay. Then they look at the comments and then they update the whole thing. And then at the end, when everybody agrees, they say, now this is the standard. And because everybody contributed, now everybody is willing to adopt it. Okay. So that's what an RFC is. Nothing technical, but it comes up again and again, so you have to understand what an RFC is. And typically RFCs are written in plain text. They look horrible. Even the diagrams, the network diagrams that you see, they are drawn using the pipe symbols and the dashes. So it looks really ugly, but that's how they do things. Okay, even now. RFCs are in plain text. Okay. Anyway, so yes.
I don't understand what's
So RFC is whenever you're trying to create a standard, you write the thing that is in your mind. So I'm the standardization organization. Let's say IEEE or IETF. Okay. The people working on that thing, on that problem, they come up with a solution, they write the thing, they publish it online and ask people for comments. Everybody in the world can say, I think this is wrong. I think you should change it to this. So we are requesting for comments from the general public. That's what an RFC is. It's a document which is put online. It's nothing technical. It's a document that is put online and you ask people to comment on it so that you can fix it. Maybe you could not find a problem, somebody else can see the problem and they can tell you and then you can fix it. Okay? So request for comments. Okay. So this RFC basically, so after comments, everybody agreed on this RFC. So think of an RFC as a standard. For us, because we don't comment on RFCs, so for us, RFCs are standards. Okay. So in this particular RFC, again, you don't have to remember the number. It's decided that some IP addresses are going to be public, which means if you have that IP address, anybody on the internet can talk to you. Okay. Some IP addresses are special and they are going to be declared, they have been declared as private, which means if you give your PC that private address, other computers on the internet will not be able to talk to this PC directly. They can talk indirectly, but not directly. You'll see what that means in just a minute. Okay. So two types of IP addresses, public and private. Private, as the name suggests, you are sitting in this lab. All the PCs over here have a private address, which means that any data that you have over here is by default protected from the rest of the internet. If you want to make any data available, you have to actually do something to make it available on the internet. Make sense? So it's default security. Make sense? Do you understand the purpose of private addresses? So they're private. They're kept separate from the whole internet. Why? So that your data is secured. Okay? And there are other reasons as well, but that's the primary reason. Okay? But obviously this PC needs to communicate with the internet. So you have to do something else. You have to put something in the middle which can do the, I don't want to use the word, but I'll use it because you've seen it, which can do the routing. Okay, so what device would that be which can do the routing? So a router. Okay, so you need a router between the private addresses and the public addresses so that the public addresses can talk to the private address. But by default, the private address is going to be disconnected from the internet. Okay, right. So private addresses are common blocks of IP addresses. Blocks of IP addresses essentially means just a range, right? So let's say 192.168 dot everything. These are private. We have examples of this. Okay, so at the right. So for example, 10.0.0.0/8. Now you know what that means. 10.0.0.0/8 means all the hosts which have the network portion as 10 dot are in this range. Okay, which means 10.0.0.0 to 10.255.255.255.255. Okay, so all of these are within this block. It's a range. If you write the numbers starting from 10.0000000 all the way up to 10.255.255.255.255, all of these are within this block. It's a range of IP addresses. Okay.
The private IP should be.
Exactly. It should fall in this range. It should fall in this range.
It's range for the same network.
Yes. Okay. So for one network, you have to have one network. Exactly. Okay. So these three are declared as private addresses. If you want a private address, just use one of these three and you get a private address by default. You don't have to do anything else. Okay. So your system is already by default protected. That is why we use 192.168 /16, which means 192.168.10.24 is a private address, right? Because it falls in this range. It's 16. So first 16 bits have to be 192.168. Everything else can be whatever, right? That is why you had this question in the midterm, so that you can understand it. And some people are supposed to take retake, so I probably should not have said that, but it's okay. Okay, so it's an important concept. So all right, so it's okay. So this thing has to be there. So 192.168.0.24 is a private address. Okay. What about 192.167.0.1? Is it a private address or a public address? So 7. So anything within this range, within this range, I probably should have made it more different, but so in IP addresses, when you're looking at them, it's very important that you look at them carefully, because if you just look at 192.168 and you say, it does, so it's going to cause problems, right? And you will be spending like 3 days trying to figure out why your traffic is not going from this PC to that PC. And after 3 days, you will figure out that you had written 7 instead of 8. So it's not a technical problem. It's like a typing mistake, but it leads to problems. Okay? So you have to be careful with this. Okay, make sense? So you have these private addresses. So private addresses are not unique. It's very important to understand what's written in the slide and what they mean. They are unique within a network. But you can have 192.168.10.1 here, and you can have another 192.168.10.1 on the other network, in another lab. In one LAN and in another LAN, they are not unique. You can have 192.168.10.1 here and 192.168.10.1 somewhere else. In that sense, they are not unique. But within a network, they obviously have to be unique. Sense? Okay. So what they mean by not unique is, in the world, in the whole world, everybody uses 192.168.0.5, so it's okay. Why? Because this 192.168.0.5 is not communicating with that, because they're both private. So they can be non-unique. Okay. But public addresses, a public address occurs only in one place, in the whole world. Okay. So if you have an address, for example, 17.1.2.9, if you have this is going to be in only one location in the whole world. Okay, so it's unique in that sense. Make sense? Why? Because it's available for communication to everybody in the world. So you have to make sure that you don't like mess things up. Is this clear? Okay. So if you're going to have a private address which is unable to communicate with the rest of the internet, but you want to communicate sometimes, you don't want to always communicate, but sometimes you do want to communicate. For example, when you open the browser, you want to communicate. Okay. So what do? You essentially, this looks like a complicated diagram. It's not that complicated. Essentially what it means is you're going to have a network over here, which is as you can see, a private address. Okay. You have another one over here, which is also private. You have another one over here, which is also private. So what you do is you put a router as a gateway for this network, and then it's the responsibility of the router to allow you to communicate with the rest of the internet. Okay, here's how it happens. Something on the internet wants to send you some information. Okay, so what they say is, I'm going to send the information to this router. Okay, and this router is going to have a public IP address. Okay, the router, so we're going to half the router over here. The router is going to have two portions. One is going to be connected to the local area network, and the other is going to be connected to the whole internet. The portion which is connected to the whole internet is going to have a public IP address, which means the whole internet can communicate to this router. Okay, that's what public means. The other portion of the router is going to have a private address, which is going to be communicating with the local area network. Okay, we have the next lab. So next lecture we have a lab in which we are going to actually do configuration which is very similar to this. So you're going to see the router for the first time and we're going to start configuring it. So this is going to make more sense when we do the practical. Okay, but you need to understand this for the lab to make sense. Okay, so the router has two portions. One is facing outside and the other is facing into the local area network, right? A router is like a door. That is why it's called a gateway. So it has two portions, one which faces outside and one which faces inside, and that is why it's able to communicate. Okay, so the public portion is going to send the packet of information to the router, and then the router is going to see, okay, this packet has arrived, which network should it go to? 192.168.0.24 or some other. So the router is going to make that decision, and then it's going to send it to its private portion, and then that private portion is going to do the communication. So things come out over here, and then the router does the translation or the routing, and then it sends information over here. Similarly, if you inside in the local area network want to communicate with the outside internet, the whole internet, you send it to the router and then the router forwards it for you. Okay? So this thing of changing one network to another network is called network address translation. So changing the address of the network. So you're going from private to public or public to private. Okay? It can be other things as well, but for now, private to public, public to private. It's called network address translation because you're going from a private address, you're translating it to a public address, or you're going from the public address and you're translating it to the private address. Make sense? This thing is called network address translation. Extremely important concept. In itself, it's very simple. But when you do it in practice, because you can have multiple networks connected to the router and multiple things happening at the same time, and you have to do the calculations, you make mistakes. So we're going to do this in lab so that it makes sense to you.
Doctor, which part of IP address is for the public and
So you give me any IP address. So give me an IP address.
No, go to the next slide. Here, 192.168.0.0.
Yes. So this is the whole network. One PC, for example, this PC is going to have 192.168.0. It has to be 0 because it's /24. Okay. 0. Let's say 18. Okay. So this address is private. If you look at an address, there is no public or private portion. Any IP address that you see is either going to be public or private. Okay. This one is private. Why? Because it falls in this range. If you look at an IP address and you say, is it public or is it private? So you see, if it falls in this range, then it's private. Otherwise, it's public. Make sense? Okay. So if you give me any IP address, for example, you say 17.2.9.15. Okay. I see. Does it fall in this range? No, because we have a 10 here. Then over here, we have 172.16. So again, it doesn't fall here. 192, it doesn't fall here. So this is public.
Means always the router is public.
One half of the router is public. Router, see a gate. So if you have a door, it needs to have two things, two sides.
The router always has
At least two. At least two, yes. Right? So a router has to have at least two interfaces. Otherwise, how is it going to create a path? If it has only one interface, things come in and then what? They can only go back. So what's the purpose of the router? It can be more than two, yes. Next lab, inshallah. Right? Why more than two? Next lab, inshallah. Because, so I'll give you an answer so that just to give you the answer. So if you have only one path going out and something happens there, that router basically like blew up or something, then all your traffic is stuck here. So you have multiple routes so that if this thing goes off, you can go here. If this thing goes off, you have another one. If two things go off, you have another one. And it's
They're doing the same thing.
exactly same thing. Okay, kind of. It's going to make more sense as we study the protocols later on.
Doctor, before a few minutes, you say if the IP address is 192.168.0. something, the gateway will always be the first.
Yes.
192.168.0.1.
Yes. So over here, your router is your gateway. Okay. So if this is 192.168.0.18, this portion of the router over here is going to be 192.168.0.1. Yes. Okay. But the private part, the public part is going to have some other IP address. Okay. Make sense? All right.
The router have two IP addresses. One is
Yes. One. So we say two interfaces. Each interface has its own IP address. It's the same thing, but more technical way of saying it would be a router has multiple interfaces, and each interface has to have its own IP address. So a router has more than one IP addresses. Okay, make sense? Okay, so I want to. So let's stop here because the other section has a smaller class, so we won't be able to fit it. Okay, any questions about this? All right, so let's stop here. Bismillahirrahmanirrahim. In this lab, we are going to set up a router and we are going to look at multiple LANs. Up until now, we have always worked with a single LAN, and we had one network in our network plan. Now what we're going to do is we are going to install a router in the middle, and as you would remember, the router defines the boundary of a LAN. So we are going to add two LANs, and we are going to see how the router allows us to communicate between these two. Now there is a lot of information in this lab which is going to be covered later on in the theory, but for now we are going to set up a router and start the communication so that we can later refer to this lab. Okay, so we are going to do something very simple. We are going to add two PCs over here, so one PC here and another PC over here, so these two are in one LAN. We are also going to have another PC and one more PC over here, so these are supposed to be in one LAN and these are supposed to be in another LAN. So we are going to add these switches. So let's go over here and add a switch, and let's also go ahead and add a switch over here. Finally, what we're going to do is we are going to add a router in the middle over here. Okay, so we are going to pick the basic router over here 4331 and put it over here. All right, so let's go ahead and do the wire connectivity. So we are going to do the copper straight through cable over here. So from this to the switch, and over here from the PC to the switch again, and from the switch we're going to connect the gigabit Ethernet 0 to the router over here. Similarly, we are going to take a crossover cable and connect the second switch over here and do the straight cables over here. Okay, all right, so now everything is connected, and we are going to give some static IPs to these PCs over here. Okay, you would remember from previous labs that we should have a DHCP over here, and that is supposed to tell these PCs what their IPs are. But for now, to keep things simple, let's go ahead and assign one IP address to this PC over here. So we are going to go to our config, and our fast Ethernet 0, we are going to give it the IP address 192.168.1. Let's say 100, okay, 101. Click here, and notice that our address over here starts with 192.168.1.101. Okay, so these three portions over here, these are called octets. These octets are reserved for the network portion. So this PC0 over here and this PC1 over here is going to have the same network portion. So 24 bits for the network portion and 8 bits for the host. So 192.168.1 is going to be the same for all of this LAN over here. Okay, so keep this in mind. Let's go ahead and close this. If you go to PC2 over here, this thing is going to have a different network address portion. So 192.168.2.101. Okay, so we're calling this 192.168.2.101. It's very important that these two be on different networks, and because I just told you that these 24 bits are for the network portion, these are different for PC2 and it's different for PC0 over here. Let's go ahead and add these notes over here so that we can later refer to this. So this is 192.168.2.101. Oops. And this guy over here is 192.168.1.101. All right, let's go ahead and move these over here. So it's this guy over here and this guy over here. Now, because these two PCs are on different networks, if we want to communicate from this PC to this PC over here, we cannot do it right now. We need to do some configurations. And if you remember, the configuration is that you need a gateway. What is a gateway? A gateway is the device which you talk to if you want to communicate with any device outside of your local area network. So this is our local area network, and the this left half of this router is also going to be within our local area network. I'll tell you what that means in just a minute. But this router is going to be part of this local area network and this local area network. So it's something which joins these two local area networks. The port or the interface with which this wire is connected for this LAN 1, so let's call this LAN 1 and let's call this LAN 2. So the port which is connected to LAN 1 is going to be part of LAN 1, and the port which is connected to LAN 2 is going to be part of LAN 2. So this router is a special type of device which is going to be connected to two different LANs. It can be connected to multiple LANs as well. Okay, so let's go ahead and click on this this router. So let's go ahead and just verify that we cannot communicate with the device. Okay, so let's go over here and say, first of all, ipconfig. So yes, our IP address is 192.168.1.101. Our gateway is not set at the moment. Okay, so we'll see that in just a minute. Let's go ahead and see ping 192.168.2.101. So when we try to do this, we are going to get a timeout or some sort of an error. Okay, so request timed out. What that means is we tried our best, we could not find any way, any path, any route to this 192.168.2.101. Okay, so that's what this means. Let's go ahead and close this. We know why that is, because this 192.168.2.101 is a different network and we have not configured our gateway. So let's go ahead and first configure the router over here. So over here in the router, we are going to go to config, and in this 000, so we have 3 gigabit Ethernet connections over here. So let's make sure that we know which one we're talking to. So this over here is 000. This over here is 001. Okay, so let's go here. For 001, this has to be on the same network as this LAN over here. This is 192.168.1 dot, and we're going to call this 192.168.1.1. So gateway, if you remember, I told you in one of the previous labs, it's by convention, it's given the host ID of 1. Okay, so now just notice the commands which are going on over here. We're going to come back to these later on. But for now, the gigabit Ethernet 000 interface, which is connected to this LAN over here, has been given the IP address 192.168.1.1. Okay. Similarly, this other interface over here, which is 001, we are going to give it the IP address 192.168.2.1. Okay. So because this is the 2 local area network, we are going to give it the IP address 192.168.2.1. So this router has 2 interfaces, one which is part of this LAN and the other interface which is part of this LAN, and the router will be able to communicate between these 2 devices. Okay, so let's go ahead and close this, and let's go ahead and enter the simulation mode, and let's go ahead and try to do the ping again. Okay, so before we do the ping, obviously we need to go to our configuration. So let's close this, config, and here set our default gateway. So for PC0, our default gateway has to be this router interface over here. So the router is our gateway, and we are going to set this interface's IP address as the gateway for this PC. What that means is, if we want to communicate outside of our local area network, we talk to this interface of the router, and then it's going to be the responsibility of the router to get it to where the packet is supposed to go. Okay, so for our PC0, the default gateway is 192.168.1.1, which is the IP address of this interface of the router. Okay, DNS server we don't need for the moment. For this PC over here, our default gateway has to be 192.168.2.1, even though it's the same router, but we have to specify the interface which is part of our local area network. Okay, so that's done. Let's go ahead and close this. Let's go to our PC over here, go to our desktop command prompt, and let's go ahead and do ipconfig once again, and this time you will see that our gateway is set to 192.168.1.1. So the first thing, whenever you're doing any sort of network troubleshooting, is to send a packet out to your gateway. Okay, so for that you always say ping 192.168.1.1. So what we're trying to do is, we're trying to establish whether we are able to communicate from our communicating device, our end device, to our gateway. If we can, then we can be sure that at least our local area network is configured properly. Okay, so that's the first thing that we have to establish. Even though we are eventually trying to communicate to PC2, we are going to first make sure that we can communicate with our gateway. Okay, so let's go ahead and run this. You get a packet over here. So let's go ahead and look at the packet. So this is going to be an ARP packet. Why is this an ARP packet? Because even though we know we are going to try to communicate with 192.168.1.1, we don't know which MAC address it's on. It's the same thing that we did in one of the previous labs. We first have to establish what the MAC address of 192.168.1.1 is. Okay, so we're going to do that really quickly. So the packet goes out. It's going to be a broadcast packet. The switch is going to broadcast it as before, and we are going to get the information back. So let's go ahead and run this a couple of times. So let's go ahead and get the packets. So this ARP packet goes out again, and this does not work. Let's try to make sure that we have the thing working. Okay, so let's go ahead and see what we are getting the error over here. So we are not able to communicate with our 192.168.1.1. Okay, so let's go ahead and see why that is. So this thing is connected over here. It's in its interface. We have 192.168.1.1. We have the subnet mask properly over here. Let's go ahead and see if we are able to see this whole thing. Okay, so what's wrong? I don't know. So there you go. Port status is not on. So even though you've done the configuration for this router, the router is not listening on this port. So this port is essentially disabled right now. So what you need to do first is to make this port come on. So this is slightly different from normal PCs and routers. Routers can have multiple ports and it affects their efficiency. So anything that is not in use is turned off. So you actually have to go ahead and turn this port on. Okay, so we're going to click on this, and this is going to turn the whole router on. Okay, so let's go back to real time, and let's go to the simulation mode again, and let's go to our PC command prompt, and this time hopefully we would be able to start the communication with 1.1. Okay, so let's see. The packet goes out, it's going to be broadcast, and this time stuff is happening. Let's see. The packet goes out, and the switch is supposed to send out the packet to the router, which it is not. So let's go ahead and see what response we're getting. Timeout. Let's go to real time and let it run for a minute. Okay, so our gateway is set properly, but we are not able to communicate with it. So we have to figure out what that issue is. Okay, so see, it works now. What was the reason? So the reason was that the switch had not communicated with the router properly. We did not make any configuration after turning the port on the router. This thing, which we have ignored up until now, you would have noticed, you can pause the video and go back and see that this thing had not turned green properly. When it turns green, it means all the internal protocols of switches and routers and PCs and everything have established connections, and the ports are now communicating properly. Okay, so as soon as it turned green, now we are able to do the communication with our gateway. Okay, but that was not our end goal. Our end goal was to be able to communicate with this PC2. But before we try to do that, let's go ahead and turn the port, the second port for this router on as well. So let's go ahead over here, go to our second port, make sure it is turned on. Okay, and then wait a little while until this orange thing turns green, so that the internal protocols have all had time to make sure that everything has worked. If it takes a long time, you can click on this fast forward over here, and after a while it should work. Okay, let's go ahead and make sure that our default gateway is set properly for PC2 as well. And now let's go ahead and do the communication between PC0 and PC2. So from LAN 1 to LAN 2. So let's say ping 192.168.2.101, and let's go to our simulation mode over here and do the ping. So PC0, click on enter. You will see that a packet is going to be created over here. So let's move this out over here, and you will see that our ICMP packet has gone out from PC0. Okay, so let's go ahead and look at this first. In our IP header source, the source is 192.168.1.101 and the destination is 192.168.2.101, which is what we need. This is in layer 3. But in layer 2, you will notice that our source is this guy over here, 129. So it's this guy over here. So let's move this out here. And in config, you will see that this 129 is this PC0. And for our router, Gigabit Ethernet 000, D401 is this guy over here. Okay. So in our layer 2, we are sending a packet to our gateway, right? So layer 2 says, this is our gateway, send a packet to this. but the destination IP address is another network. So when the router sees this, it's going to send this packet forward and it's going to change the layer 2 information in this. Okay, so let's go ahead and click on this. So this packet over here, you see the Ethernet layer 2 is changed. Why? It's saying the source is now D402, which is the second interface, this guy over here, D402, which is the second interface. So what the router is now doing is that it's taking the packet, it's changing the layer 2 information. It's saying that this D402, I'm the source now, no longer this guy over here. The MAC address of this PC0 has disappeared. I am the source now in layer 2 and I'm sending this to who? 192.168.2.101, but because I don't know what the MAC address of that is, I'm going to run an R protocol over here. Okay, so make sure that you understand this. Right now, the objective is to send this packet to 192.168.2.101, but because we don't know the MAC address of that, we have to run the ARP over here. This is going to be a one-time deal. Once the router knows where that packet is going, this information is not going to be needed anymore. Okay, so let's make sure that this ARP runs. So ARP goes out, it's a broadcast, PC2 is going to accept it, PC3 is going to reject it. You should already be familiar with this. The packet information comes back, and when the router, the second interface of the router knows where this thing is, it's going to send out the ICMP packet, which is the ping packet. Okay, so let's wait until these STPs are done. So there you go. A little more of the STPs and some other CDPs going on, DTPs. Let's wait until this is done. So there you go. In the meanwhile, while all of this was happening, PC0 did not get any information out. So it has decided that, well, request timed out. Okay, but this was because it was the first time it started the communication establishment. Okay, but once that has timed out, if you now send a packet, the router already knows the MAC address of this PC2, so this is going to go through properly now. Okay, so let's see if that's the case. So another packet goes out. Now there is no broadcast because we know where our gateway is. We go directly to the router, and now again there is not going to be any broadcast of the MAC layer because the router already knows where the information is. Okay, so see, this ICMP packet directly goes out and reaches over here. And in this ICMP packet, you will see that the source is 9A and this is this guy over here. So this is what's going out. So in layer 2, the router has changed the information of the source and the destination. Initially, it was the destination and PC0 was the source. Now it is the source and the destination is this guy over here, PC2. So let's make sure that that is the case, 9AEB. So that should be this guy over here, 9AEB. Okay, so hopefully this is making sense, and the source and destination is the same. And now this thing is going to send an information from 9AEB, which is this guy over here, to this router interface, so the second interface of the router, with the destination as 192.168.101. Okay, so this guy over here. When this packet gets to the router, so let's send the packet to the router. When this packet gets to the router is going to change the source as its own and the destination as this guy over here. Okay, so the in layer, the packet which came in had this source and this destination, and now it has changed it to this source and this destination, 0129, which is this guy over here. Okay, so fast unit 0129. So hopefully this is making sense. And now you can go ahead and run this packet and it's going to go out and reach the proper PC. So now what we've done is we have introduced a router in these two networks. And if you remember, I told you that as soon as you have a router and you understand what a router does, now you can go ahead and add multiple different local area networks. For example, you can add a local area network over here, you can add another local area network over here, and the router is going to take care of everything for you. There are quite a few different router configurations and different things that we have to do later on in the course. But for now, you have established connectivity between two LANs. One very important thing is that we have given this thing a static IP address. Instead, what you should be doing is adding a DHCP over here, and the DHCP should give out the IP addresses to these PCs, and it should also specify that this gateway, this router is our gateway. So for these PCs connecting over here, the default gateway is 192.168.1.1, and for these guys the gateway is 192.168.2.1, even though it's the same router. Okay, so make sure that you understand that, practice with this, and make sure that you can establish connectivity by sending pings from one PC to another and from the PC2 to PC0 as well.